So far, we have talked about several process synchronization concepts. So actually, those concepts can be applied to thread synchronization. So for those mechanisms, there is no big difference between process and a thread. So now it's time for us to apply those theories to your programming assignment or your project so that you can use those synchronization mechanisms into your own code. In this slide, it shows us how to use Mutex locks with Pthread in Linux system to synchronize the threads in your assignment or project. So as we already mentioned in the previous slides, we can use the Mutex locks to protect the critical section of your code. It is pretty straightforward. So you try to acquire the lock before entering the critical section. After you exit the critical section, you have to release the lock so that other threads can have a chance to grab the lock and access their critical section. Down below shows us the rough code about how to use the Mutex locks to achieve thread synchronization. At the very beginning of this code, so we need to include the pthread.h, this header file, so that we can use the pthread functions defined in it. Then we define a special type of variable, mutex, which type is a pthread mutex t to hold the lock. After that, we need to initialize this variable with a function pthread mutex init function. And we also need to pass the address of mutex to this function as a parameter, so that the initial function can assign the default value to variable mutex. The other non-parameter as a default value will be passed into the initial function as well. So currently, the default value is good enough for us to operate the lock. So later, if you want to know more and do more things with those parameters, so you may refer the online Mutex lock library to further dig out more information there. And after we have prepared the lock, so we can try to acquire the lock to see if it is available with the function pthread mutex lock. So, and also we need to pass the address of the lock to this function as a parameter, so that later the operating system can change the value of the lock to indicate whether the lock is available for this thread or not. And also, this lock function will return an integer value back to the thread to indicate whether the current thread gets the lock or not. But for most of the time, we do not need the return value. That is why we did not have any integer value to hold it, an integer variable to hold it. If the current thread is failed to get the lock, due to the lock is in use by other thread, so the current thread will be blocked until the lock has been released. Then the current thread may have a chance to get the lock. If the current thread get the lock, the critical section can be executed. Right after the thread finish the critical section, immediately the current thread will call the pthread mutex unlock function to release the lock, so that other thread can get the lock. And also, do not forget to pass the address of mutex as a parameter to this function. So far, we have mentioned the three pthread functions, which are initial function, lock, and unlock functions. Another pthread function I would like to mention is pthread mutex try lock function, as I have drawn on the left corner of this slide. So this function do the exactly same function as a pthread mutex lock, but the difference is that try lock function will not block the thread. It will immediately return a value back to the thread. If the value is 0, it means the thread get the lock successfully. If a non-zero value has been returned, it means the thread does not get the lock successful. And usually we will use a while loop to combine with this function to get the lock. So we use the return value from the try-lock function as a condition for the while loop. So through this way, we can achieve the busy waiting by our own code. And the last thing I would like to mention is that the command line which is used to compile your code, the command will be like gcc ucode.c-lp thread, as I have a draw on the right corner of this slide. So do not forget to add -lp thread at the end of your command to link the Pthread library into your program. Otherwise, the compiler will complain that it cannot find the Pthread functions you used in your code.